Hello, my name is Kiefer Young, and this is Physics Lab 1, the Charge Tape Lab. So the purpose of this lab is learning about the transfer of electrons, and we're going to be doing this by using charge tape and determining their charges both experimentally and computationally using code. And a preview about this experiment is that the point charge that I calculated is 7.96 times 10 to the negative 9 coulombs. Some assumptions that can be made is the charges on the tapes are equal. The charge tape is equal to a point charge, and that there's no air resistance in this lab. So the equations that we use are the electrostatic force, K Q1 Q2 over R squared. Force of gravity, which is mass times gravitational, and F equals ma. For F equals ma, that there's no acceleration in this, so F net is equal to 0. For our procedure, initially the tapes have no charge, so we have to create the tapes negatively charged. So we tape the U tape to the base tape and pull it apart, and we do this twice. The U tape becomes tape A and tape B, and then we place tape B in the air held by 2 points and place tape A under tape B, and since they're the same charge they should repel each other, and then we record the distance between the two tapes. So for my observations, the length I got for one of my pieces of tape is 0.18 meters. Clear tape is around 1 gram per meter. This means that the mass of my tape is 1.8 e to the negative 4 kilograms. What was the distance between your two tapes when one began to float above the other? And that is 0.018 meters. The calculations that I did was the magnitude of the gravitational force on the floating piece of tape. I calculated that as 1.76 e to negative 3. What was the magnitude of the electric force on the floating tape? That should be the same since F net is equal to 0, and the only forces are the electric force and the force of gravity. For the calculations part 2, I calculated the charge of the tape, and that should be Q is equal to 7.96 e to the negative 9. And I also calculated the electron deficiency, or at least I determined that it was electron deficiency by taking Q divided by the electrons, which is 1.6 times 10 to the negative 16. And I calculated that 4.97 times 10 to the 10 electrons were lost. And for my final part of calculations, I calculated the total atoms on the tape using the atom area, 1 times 10 to the negative 10 meters per atom, and since we're using area, I had to square that. And then I had to calculate the tape area, which is just length times width. And then by taking the tape area divided by the atom area, I was able to calculate the amount of atoms on the tape. And using that, I can find the atoms per electron, which is 7.24 times 10 to the 6. Now on to the computational side. I used a GlocalScript code, and I found the charge of the tape is 7.973 times 10 to the negative 9 coulombs. The deficiency of electrons on one piece of tape is 4.98 times 10 to the 10. And there are 7.224 times 10 to the 6 atoms for every electron. So some errors in this is that in the experiment is that the charges on the tape are likely not equal. Charges on the tape may have been lost due to the contact with the tape, and the tape is also not a true point charge. For our discussions, what if electrons had a positive charge and protons had a negative charge? What would you change about the observations you made with your tape and the other charged objects? My observations would be very similar due to the same charge being able to repel each other. So if they were both positive charge instead of negative charge, they would still repel. Why is it important to handle the charge tapes with as low as possible? What happens when the charge tapes come into contact with your hands or other objects? The charge tape will neutralize by gaining electrons back. And here's my glow script code. It's also shown on the computational slide, and that concludes my presentation.